This is problem 19-89. The table fan exhausts a 10-inch diameter jet of air with a density of 0.0749 pounds per feet cubed, having a speed of 20 feet per second. If the fan weighs 5 pounds, determine the minimum coefficient of friction between the fan and the table for which the fan will not slide. Okay, so what we need to do is first we can just talk about this fan in general. I'll just draw some kind of like fan shaped object. And actually, there's like, I guess, a stand here too that's important. And then we will talk about the different forces that the fan will have applied to it. And first is that we are given the weight. So the fan is 5 pounds. And then the fan is going to be blowing air, and the air is going to be pushing back on the fan. So we'll call this force B. Then the fan is sitting on some surface, so there will be a normal. And the problem is telling us that there is friction. So there's going to be a force of friction that is going to be at the base of the fan. Now, because we know which direction the fan is pointing, and we know that the air is going to put a reaction force on the fan to the left, we can assume that the friction, being the only other horizontal force that we are aware of, will be moving to the right. All right, now we have to understand how the airflow, how this air column is going to work. So we have seen in past problems when you have mass input to a system and mass output from a system, you will have different velocities and areas, cross-sectional areas for the intake and the output of the material, whether it's water, air, and in a previous problem, sand. So what we have to do here is try to imagine what is going on. And we're of course going to not talk about the true system, but more of an ideal close enough approximation. So if the fan is pushing on the air with a force B, and I'll draw air as like a column. So we have the air coming out and kind of being focused a bit. All right, so this is the velocity of the air coming out. We are grabbing air, well, I mean, yeah, basically from right behind the fan blades, but we are technically, and I don't completely like this. And again, this is because we are trying to make the problem workable. We can somewhat just write off the area and the velocity of the air coming in from the inlet, because the fan is grabbing air from pretty much everywhere behind. So there is air being pulled in from all directions as an inlet to the fan. So basically we can give this kind of like an infinite area. I know that that might be a little bit of a head tilt for some people, like really, like infinite, you know, like obviously if the fan's in a room, it's not infinitely big, but we can more or less neglect, and therefore we don't have to calculate a velocity. We can say that the velocity is 0. If this doesn't bother you, you're lucky. It bothers me a little bit, but I know why we're doing it. So therefore I am like, okay, this is just what we do as engineers and physics people sometimes, is when we know something is nearly negligible or actually just negligible, then we can ignore it. You're going to see all kinds of examples of this in all kinds of other topics in the future, where we just kind of ignore something because it's close enough. Okay, so the inlet velocity of the air on the left side of the fan is basically close enough to 0 that we can say 0 velocity. All right, now let's just go with that and move on with the math. Well, one of the things we want to do is find the volumetric flow rate. So we can find Q. And then here we go again with the pi over 4. Remember, the 4 is the dividing the diameter by half while it is squared, but I have pulled it out of the square term. And the diameter of the fan is going to be 10 inches. And then we divide by 12 to convert to feet. And this is the radius squared, but we pulled the 2 out and the 2 squared out. Okay, just I keep trying to bring that up so in case anybody didn't really catch that or forgot since the last time that I mentioned that in a previous video. Okay, and then times the velocity, so 20 feet per second. All right, that calculates out to be 10.91 feet cubed per second. Okay, then we can get the force. So the force of the air is B, and we are given the density, which is 0.0749. All right, but we want the, I'm sorry, that was in pounds per feet cubed, so that is the specific gravity. So make sure you're paying attention to the units in the question that's given. So we need to calculate the density by dividing by the acceleration due to gravity. So that's the density, all right? And then we have to multiply by the volumetric flow rate, okay, 10.91, and then multiply times the velocity, the difference in velocity between the inlet and the outlet. Well, that's going to be the 20 feet per second minus the nearly 0 feet per second on the inlet. All right, that calculates out to be 0.507 pounds. So that's the force of the air leaving the fan. All right, so we have the value of this force. We still have 2 more unknowns. We don't know the friction and we don't know the normal force. And those are one in the horizontal, one in the vertical. So we need 2 more equations, and hopefully that makes it obvious that we need a horizontal equation and a vertical equation. So we can do sum of the forces in the x, and this will be equal to the force of friction minus the force of the air equal to 0 because the fan is not accelerating. And also we'll have some of the forces in the y, and that's going to be equal to the normal force minus the 5-pound weight equal to 0 because the fan is not lifting off the table. Okay, so if we solve, we will end up with a normal force. That's the part that's most important. I hope you understand why, of 5 pounds, right? Because ultimately we're trying to find the friction. Well, in order to solve for the friction coefficient, I'm sorry, not the friction itself, but the friction coefficient, we have the friction force. Sorry, I did lowercase f, let me be consistent. And that is equal to the coefficient of static friction times the normal force. Well, the normal force is 5. And then if we solve for the friction, which up here is 0.507 pounds, it's basically the same as the force of the air, then we can solve for mu, static coefficient of friction. And by the way, that answer is 0.101.